So, mm, okay, okay, sorry for the slow start. So this is part two of the live coding I've been doing for minGPT port to JAX, which we coded a little bit with David at the end, who's not here right now. Uh, so I did some stuff offline, which I'll be explaining for those who were interested. I got some feedback uh, from the last episode. Maybe, yeah, I'll go. Maybe I can go over the feedback. Um, so let me see. Um, okay, so where is it? Okay, so last episode, um, like I was done porting Min GPT, and I got some feedback like from Matthias, like why not port Nano GPT? And that was kind of a good question. I dug into Nano GPT. So initially, I read that Nano GPT was supposed to be a little bit more optimized with some stuff like, let me search for it, flash attention. So so what I understood initially was that Nano GPT was going to have like some additional stuff like flash attention and and who knows what other stuff. So I was like, okay, this is not good, but it turns out, as I was looking through it, it's actually a simpler repo. So I don't know. It's a question for Carpathy. Like, is this really like the optimized version, or just kind of a like a like the next implementation without the hassle of everybody sending PRs, which the other repo had a lot of PRs. So I ended up coding like very similar to last stream, but I just let me close these other windows. Uh, I just started using Nano GPT-JAX, which uh, turned out to be a little bit nicer. So I'm gonna go over the deltas, and then I think today I wanna try um like doing like starting to construct the training loop. I think that would be the idea for today. So, but I want to give like a TLDR of the of some of the changes that I went through. So, okay, first thing is that now Nano GPT uses a data class. That is awesome because I spent a little bit time trying to fix the old way of creating the configuration. Uh, Second thing, okay, I have here the old file for comparison. So here, Karpathy starts doing like new Jelu, like it's kind of a faster version of GLU, uh, and it turns out that in JAX, uh, there is already like a DLU layer activation, and what Caparthi coded was, you could activate that under a flag. So just set up proximity equals true, and that triggers the fast version. The formula, I checked that it was the same. So yeah, this I just erased it. Second thing, which was kind of a more interesting change, I the other time I basically just tried to do like a very quick port, so I didn't spend too much trying to figure out what was happening. This time I did some, yeah, like I was thinking through the code, especially like trying to see if I could simplify it using some of Flax primitives. So the whole idea of speeding up like attention is to do like a single matmul. Uh, so if you check here in in this part, it's doing like a linear activation, and then it's doing some reshaping in various ways. Uh, so one of the things to note is that this has uh, like all the heads in this like an embed. Oh no, sorry. Uh, Here in linear, you have the n embed times three, but this n embed contains like all the heads. So then later on, you have to split it into the number of heads, and also you have to split it into the key query and value. So you kind of have everything like concatenated, and you have to split it. Uh, so what I did is that uh, Flax has this layer called dense general, and in dense general you can give it like a shape, and the kernel will have that shape already, and the output we also have the additional, well, additional in case there is something additional dimension. So I just put here in heads, and this I do leave it uh, like here, uh, and that uh, the result is that when you compute it, you have the head size already here. So you don't have to do like the fancy reshaping, but you do have the key query value concatenated here, uh, and you still have to do the swap axis that is done here. So what I did was move do like the, well, here it's called transpose, but do the transpose first, so it does it for layers. I don't know. In my mind, that is like an optimization because you do it for all of them, and then, although I don't know if that is possible in this formulation, but if you do it before splitting, then I think it's better. So that's what I did here. I did the swap axis first, and then here at the end, you just split. I put it in 3 lines, but you can do it like in two. I did here just to have like clarity of the shapes. So that is one simplification. Second, this is using a little bit more of JAX tricks now, oh, I'm gonna maybe take uh, David's advice and make this bigger. Uh, okay, hopefully it's good. So second thing, I tried to like make a little bit more of a JAX, like a more correct version for JAX. Would be this this register buffer. Uh, like last time I just turned it like into a property, but I wasn't like too sure how or what block size was doing. So block size, after looking at what it was doing, it's simply the max length of any sequence. So what Carpathy was doing is he created this matrix like at the beginning, and then later on just slice it, and that was kind of it to the size of the input. In the JAX world, well, I mean, you could try to register that matrix, like on the weights or something like that, but then I don't know, you have to keep that state around, which is like maybe undesirable. But you can do another trick such that it behaves like a constant. Okay, first, if like these programs are compiled, so I think uh, if you just do something like, copy it like this, just doing it on the fly and have it recalculate this, maybe like the JAX compiler is smart enough to know like, okay, I'm just creating this thing for this shape, and maybe it can try to work out like, oh, this is sort of a constant. I don't have to a constant given t, like for every size of t, it will just pre-calculate it or something like that. If it doesn't, and you want it truly to be like a compile time constant, such that it's not calculated over and over, then JAX has this ensure compile time eval decorator, and it will make sure that everything within this constant context is calculated uh, like at compile time. So I think the term they use is staged out, something like that. But anyway, if you do it like this, this will be like precompiled, and it will not be like, it will be treated like as a true constant. So you can also do it with NumPy. Yeah, yeah, you could have done it with NumPy. Maybe, I don't know. Maybe not, because maybe you want to use it. Yeah. Okay. So the idea is to have it as a constant. Maybe there's other ways, but with this context manager, you can do it. Uh, the other thing, yeah, I think that was okay. There are like three changes. This was one, like no slicing. You just calculate this for the correct t, and that is it. Uh, the next thing, probably, I think the rest is there is not much difference. Uh, okay, the last thing that was actually a little bit different is that, okay, yeah, first I removed the transformer uh, module dict. I know I just removed module dicts altogether in this one. I don't know. I just assign it to the module. I don't know what's the idea of. hiding it, hiding this. So I just did it like that. Uh, but if you look at the PyTorch implementation, there is like one detail, which is the head. So the head here is implemented like as a linear uh, output, and then it uses the same weights. Okay, okay, I'll be curious that it's done in this order, but here they create uh, the basically the token embeddings first here, and then they tie them. And the way they tie them is apparently in PyTorch you tie them like this. Uh, so you just set them equal to each other, and then they should actually be the same object. Um, so you you cannot really do this in Flex like this. Also, I'm very curious why it was done like this instead of like backwards, like something like this. I wonder if there is a difference, but in my mind, these are the original, and then the output. Uh, I guess this doesn't matter, but it's just kind of a why this order was picked. Like, okay, in my mind, you're tying these weights to the ones of the embeddings because you want the outputs sort of be the same as the token embeddings. It should be shared. Uh, so yeah, just kind of a why the order, but if that doesn't matter because they're the same object, then on the flag side, you don't have that. I don't know if there's an easy way to tie weights. I think anything that is acts like a reference is really hard to model in Flex and JAX. But uh, since it's a very common operation on the JAX on the Flax world, you actually what you do is that you don't define the output layer. The Well, I guess this is a language model head. What you do is that the token embeddings they have this method called attend, and attend is basically using the weights from the token embeddings. It does a, a linear transformation. If you just look at what it's doing, it's just calling dot the transpose. So basically, you get the weight tying there. Uh, so that's how you do it in Flax. And I think those are the deltas from Nano GPT. And then I just just verified in a simple test file that we got the same numbers. So here I am just using the same config for both, which is the standard one, and I'm importing the like the PyTorch version as the PyTorch, and then I'm creating both. Uh, this one will print the number of parameters on it, and for the Flax version, I'm using tabulate just with some random inputs to see what happens. And if you run it, it will take a while, uh, but at least what I got last time. the weights, the weights are the same if it finishes. Uh, and actually, this number is the same thing you get from Hugging Face. So seems to be like the correct number, universally accepted. So yeah, we also get the 124 million parameters. So that is very good. It it seems that the port of the at least of the network um, is correct. So that is kind of my recreation of what I did live last time. I did it offline with NanoGPT, and then I actually spent a little bit of time analyzing, like, okay, what can be done on the JAX side to simplify it. Uh, and this is uh, this is what you get. I think I can remove all this. And okay, yeah, here's where we are. Uh, is this ones. Yeah. So maybe what I wanted to do in the next maybe 40 minutes to 1 hour is um, trying to create like a simple training loop. So nice thing about this repo is that it's super simple in in the sense that it's just like a bunch of scripts. So I think train is the one that uh, does like the training, the actual training. So this probably behaves like a main script, but let me see if it accepts flags and all that stuff. Maybe it doesn't even accept flags. It just I mean you just have to edit this file instead of having like a command line. I know it should have a command line. Let me see the README. Uh, yeah, train.py is where we are, and it does accept some flags. Let me see what it's using for parsing. Uh, maybe some PyTorch thing. Configure read writes from command line. Wow. Okay. Okay. It's very hacky. What the heck? Okay. Okay. Yeah. Why all this? Uh, so it seems that if you just run, if you just put stuff in the keyword arguments, it will execute. I don't know how common this is. So it's kind of a I don't know like a poor man configuration system, something like that. Um, uh, okay, yeah. Let's just keep what what is here, so we don't mess with that. Uh, and I think I will do the same. I will create the PyTorch copy, and then I just start modifying this one for my needs. So I think one thing I want to do is remove Probably all the PyTorch stuff. Yeah. So let's just import JAX. Numpy as Numpy as NumPy. Uh, this will trigger errors, so let's see where the errors are. So running using data parallel in Flax and JAX, it's going to be different. So we're actually not going to use any of these. So this goes away. We can maybe later use some of the parallelism strategies. So this goes away. Okuda. Uh, yeah, I don't know. All that goes away. What is this? Autocast context. Yeah, let's just kill that. Uh, okay, this is loading the data. Uh, maybe this numpy map. Okay, the data is being loaded. I wonder if it's loaded everything into memory of, or this map is somehow a bit magical, or will I get like a, I don't know, like an error at some point? Well, what I can do is just put a breakpoint here and see what's up. Maybe let's just do that. Uh, should be fine until here. Okay, we need the data. Let's see, the data should be under a command. Okay, it's these two commands. Uh, so see, okay, we need to add a couple of stuff. So I'm guessing we need these two for now. Three. Add. So let's add the tokenizer. Okay, it seems I also need datasets. So I'll do it after this. Wait a second. Okay, let's see if we can get the data. Okay, so it's 12 gigs. I wonder if I have space. Um, let me run cd um, in a machine that tends to run out of space. So I might have to delete something. 12, okay. So I'm just gonna delete some stuff. Here, C simple VM. Gonna delete a couple of virtual environments. Here, because those can be recreated easily. See, okay. EDPM-JAX. Next one. Okay, maybe I have enough space, so we don't run out of space. Uh, okay, this will take a few more minutes, so I'm just going to continue for a bit, just looking at the code. Maybe let's continue porting it. Um, assuming this works. So, okay, what is happening here? It's converting stuff to torch. So I guess I just converted to NumPy. Converted to NumPy. So this is doing like dynamic stuff, and then I'll convert it to JAX at the end. This could be like option um, stack. Okay, we don't need this. So what is happening here? We're doing like a slice, and then okay, we're doing a slice with some block size converted to int 64. Um, int 64. I wonder if this is wrong, but I don't like int 64 index. So I'm gonna convert it to int 32. I wonder if that's very wrong, but I don't know. Eh, so why are we doing this twice? Okay, we're striding one to hit our target, I think. Yeah, we seem to be striding by one. So okay, all this is just by, and then here we just convert to JAX, JAX, and we can actually put it in the device, I guess. Input X and Y. Um, I think it will put in the default device if we don't specify anything. And uh, in the future, we can actually customize this to shard the data. That would be cool. Okay, so the sim DC, uh, once the data finishes. So, okay, let's continue. Attempt to derive the vocab size from the data set. Okay, yeah, let's just keep that there. Mm, largs is fine. Just initializing the model. This okay. It also handles resuming. So here we might have to actually do like initialize weights because on the JAX side we don't have weights initialized. Um, so so maybe we could try this. Um, so variables equals model init. Okay. Let's see. I think this is right. Let me just look at my test file. So we just need to run. Yeah, we just need to run something like this. So doesn't actually have to be block size. can be whatever, and just do something really small. So a sequence of one sequence of two tokens, and okay, we have extra stuff. I think this is enough just to initialize it. Um, so I guess uh, we can try the non. So maybe we don't support like print resume something not supported yet, and then we exit, do something like this for now, and here we do something similar, print initializing from EP2 wait, not supported yet, and then exit. Uh, this way we can continue. So we're just gonna create like, I guess let's put it as params here. Leave it as variables. Um, Model is possibly unbound. Okay, maybe we should just raise eh, like a runtime error. Okay, I just implemented the else. So now it's sort of well defined. Uh, okay, so I do remember this. There is a crop block size model method, uh, which I haven't ported yet, so I think I will have to do that. Uh, on surgery to decrease the block size if necessary. We may need to load GPT pre rates and block size but one smaller. Okay, why are we doing this? If block size is less, crop down the block size. So we need to do this a little bit different. Uh, let's see. Maybe we can get creative here. Um, can we do this kind of stateful operations? That's what I fear. No space left on device. Um, let me see. Okay, JAX streams. Uh, yeah, I think I'll have to nuke Flax's VM. And C close VM. I hope that is enough. Else, it's gonna get a little bit complicated. Extracting data files. Okay. Seems to be a little bit slow. Might take a while. That would be very sad. I think I should have done this before running this, but I didn't know it was gonna take so long. But we can solve this other problem of how to do some parameter surgery. So I think what we can do here is turning this into like a static method uh, that takes in. Let's change this for like a module, which is of type EPT, a block size, and then it also takes variables. Uh, okay, now maybe we can leave this as a method. Yeah, but we have to bind it to the variables outside, so that is going to be like a trick. Uh, so what is? It's just slicing. It seems that it's just slicing. Uh, so let's see. Okay, here it's just slicing, and here it is cutting the bias. Okay, I think we can do this differently. So, what if we just take variables? Uh, Variables and block size. Uh, and ooh, it's gonna alter the config. Okay. Does that do anything here? Yeah, that is legal. That is legal. So in Flax, from Flax dot let's see iter utils traverse util port path aware map. So what I think we can do is just do like a map, because this is what it's doing. It's doing some parameter surgery. So a tool in Flax is using this path aware map function. So what it does is that it yeah, maybe crop weights. We can create like a function like this. Takes a path, and then it takes like an array, so something like x, and then what we can do is transform x based on the path. Uh, so here is an example. We we can, so it's like a tree map. It only works for dictionaries, by the way, but it it gets the path in the by tree to that instance. Oh, there is a new JAX API to get path for arrays for trees. I wonder if we can use this in the future. But for now, in Flax we have this function, and what we can try to do is, yeah, just detect if we're in one of these cases. So so by the way, path here is um like a tuple of strings. So that uh, so we can say something like, if wait should be, so this is the embedding thing. It, where it's it. So let's see what name embed uses. Embedding. Uh, let's see what we're coding here. Uh, path and path minus one equals embedding. So to be the embedding for the positional embeddings. Uh, Actually, maybe you can do it just like the last two elements are WPE and embedding could be a little bit easier to understand. So that would be this case. The other case would be the bias. What is okay? The attention biases. Okay, so we this one we don't have to do actually because these these are just compiled every time. Uh, so we don't need this. Uh, and okay, that was kind of easy actually. So just comment this to have it here. This is what we're doing. Uh, yeah, actually just return this. Okay. Uh, question is, are we cropping in the right dimension? Just a second. Yeah, it seems it's the first dimension. Okay. So okay, here we need to return x. Yeah, yeah. I think this is good. So okay, no space left on this device. That is a little bit sad. Yeah, yeah. Has 97 gigs. What is this? Why are there 168 gigs? Dev.temps. Like there's more space there than where I'm running currently. Okay, cannot access it. Yeah, I'll have to see how to spin a bigger machine. But I think we can try. We can do like a little simple fix just to run things. And it's to pretend to load something. So it just be stuff. So Actually, maybe we can just do it here. Of this for now, we just randomly generate some samples. Uh, oh, but do we need this validation data? No, we're not using it anywhere. So, just like np dot random dot uh, randint from 0 to block size, and then just batches of 32. Okay, sequences of 50, whatever. And then, okay, this seems to be just shifted by one, so maybe this is data. Then X is just kind of a slice. Yeah, something like this. Okay. Um, yeah, we can fix this later. We'll probably get stuff here if exists metapath. Let's see where we get this time. So let's just run till here. Usable temporary directory. What? I might need to delete the data. The data is here. Okay, let's see if we now have space to run this temporary directory. Oh, usable directory. It's very weird. Poetry. Oh, okay. So again, let's try to run this. Okay. Yeah, something was weird there. See, does this exist? Okay. So here we don't have to worry about this. Okay, this is a part I was interested in, the initialization. Okay, we're missing one argument, train, so n equals false. Sorry, train equals false. Um, let's run again. Okay, this is good. Uh, okay, we're running on CPU. We can fix that. Okay, we got here. So let's just run this again. Obviously, 2 device doesn't exist, but we can jax.tree app mp.shape variables. We do have our variables. Uh, we won't do the cropping by default. Um, Seems that we didn't have to worry about that, but we solved it anyway. Uh, Next thing, okay, configure optimizers. Okay, let's see. This is very torchy, so we will have to see how to convert this to optax. Okay, this seems to be just doing like team group. So for the parameters, they have like certain decay, and then for other groups of params, they have a no decay, and then so in optex you can also do this just by configuring like different optimizers for different weights. So maybe we can reuse a little bit of the logic here to map it to its corresponding optimizer and just make sure that you have like the correct logic here. Um, so here we need to return an optimizer. So the only thing additionally that we have to pass is like the variables. Uh, yeah, variables. Need like the variable structure. Let's see. Okay, here stuff. Certain things are being done by type, but we cannot really do this by type. So let me just do something. Search.mn. So I have these available. Um, names. So let's see if we understand the logic. This should be easy. If we use again uh, path aware map, because we should just be able to. Okay, so let's let's see. So path aware map was actually created for this exactly, to create like multiple optimizers. So if we look at the documentation, it's not here. But if we go to Flax's uh, transfer learning guide, there is an example of what we have to do. So let's just copy that example. So maybe just paste it uh, here at the bottom. So um, so it seems here there are two groups. So we probably need to also create two groups, but we have to give them a name. And it seems that we can name them decay and no decay. And so let's see. Decay. So um, we have to define each optimizers like each optimizer ahead of time. Um, so what is this weight decay? Oh, this weight decay we get it from the outside. Function conversion doing something very simple and is very defensive. Okay, we're separating all the parameters for the one to bucket cells that will experience weight decay for regularization and those that won't. Ah, yeah, I wonder if this could be done simpler because okay, weight decay for regularization. Those that want. Wait, okay, and then wait k0 for torch. Oh, wait decay coefficient. Uh, okay, so let's see. Wait decay. Okay. Uh, so it seems here we have our learning rate, right? Yeah, learning rate is okay. We also got the betas. Okay, thank you, Copilot. So okay, yeah, it seems we're gonna create two optimizers identical except for the weight decay. Uh, so maybe like get optimizer and then decay. Uh, do something like this. Return. Okay, and get optimizer for weight decay. Okay, so let's just inline this. So we're gonna create two optimizers, and the other one will be with a decay of 0. So that will be the partitions. Then let's ignore this aware map. Okay, now here we have to define uh, like this logic here. So we can do like a function. Uh, so this function should correspond to this. Maybe let's create it. Create like a def a party partition font. We get the path, which is a tuple, uh, and then we get x, and let's return x for now. So, oh no, here we have to return something like decay. Uh, So we have to return the partition for each weight, for each parameter. So, but let's just plug this in here. Variables. So, okay, let's not use the variables actually. Let's use params because yeah, we don't want to pass something that is not a parameter. And then these are the param partitions. Is good. And then yeah, this works great. Uh, could do this as a like debugging thing. Mhm. So for traverse util, um, okay, now maybe yeah, this wasn't necessary. Uh, let's remove the import. Yeah, we can just print param partitions if we want to debug it. Here we return the optimizer. So pending, obviously, we have to port the logic to the param partition function, but we at least currently have our two optimizers using optax, which they're the same atom but with different weight decay. So what is the logic? Let's see. So all biases will not be decayed. Okay, that is easy. So let's see. Sure. So we can do something like this. Okay, so if path minus one equals bias, no decay. Okay, this is great. It seemed to invert it from the torch stuff. If it ends with weight and it is not on the white list, okay, this seems to be like the hard part. because we okay. Let's see. Okay, they share the same name. So apparently they are named Wait, so they have to see what what the name is called. But maybe here we can do it differently. So layer norm, uh, normalize. Oh, okay. This see the logic. The basis will not be decayed. Okay. Weights of whitelisted modules will be decayed. So we will decay uh, dense weights. Let's see. Okay. So we have scale and bias. I imagine that we will not be decayed. So we don't want to decay layer norm and embeddings. So no decay. For layer norm, so I guess we do have the bias. Okay, what is the name in the torch world? In the torch world, it's I erased the one in the torch world. Uh, okay, it's weight. Yeah. Uh, let's see. I'm hoping this is just the scale. Is the only thing that might be called the weight here. So let's imagine one hour here, or let's see, like param name equals a path minus one. So if bias or scale no decay, and we're missing one, which is the case for embedding. So let's see, what is this called? Uh, so it's called embedding. Uh, So hey, that was easier than I thought. It seems we don't want to know decaying anything that is called bias or scale or embedding. Uh, there is some other logic. Let's see what the other logic is. But so yeah, no bias. Weights nothing from layer norm or embedding. Layer norm has only bias and scale. So if we just blacklist bias and scale, that would be good. And then we also blacklist embedding. Oh, so it seems these are like mini blacklist. Should cover all the cases, else decay. What is this doing? Validate subtle are tied, so they will appear in decay and no decay sets respectively. This is false for us. We don't have that problem. It doesn't return duplicates. It will only return the first occurrence by those. So let's manually remove away from the case set. Okay. We don't we don't have to do this. Validate, validate that we consider every parameter. Okay, this is just a validation. Okay, it seems that the logic was rather simple, but there is validation, and we didn't care about this. So actually, for us, it's just this. If actually, it's just this. So evidence with bias scale and braiding, no decay, else decay. Uh, you don't need um, so first, yeah, okay. Wasn't that hard? Uh, let's just comment this out. Yeah, no, actually, you can remove it and then just look at the PyTorch code. Uh, Leave the comment because that is what we wanted here. So configure optimizers. Seems just we go back to a training code optimizer. eh, we will just give it the params. So yeah, actually, let's create the params. Sorry, the params here. Equals. Ah, no, let's do it. Yeah, no, let's do it here. Params equals variables params. and then okay, we coded this. Let's rename variables params here also. So params equals yeah params and block size, and then here params. Okay. Um, can actually reach this code. Let's really bugger until this point. Hey, Mark was around. Hey, Mark, I don't know if you're still there, but nice to see you. Yeah. Oh, okay. It's almost an hour 40. Might end this stream soon. But let's see what we got. Need to do something to have the chat visible. Um, Set up a second screen. So what I wanted to do is just look at the partitions and see that we got what we expected. So let's see, embedding, no decay, that is good. Um, so so bias, no decay. Let's just explore one of these blocks. So scale, no decay, bias, no decay, perfect. In the attention, decay for the kernel, no decay for the bias, that is perfect. This layer normalization, no decay for anything. And for the MLP, decay, no decay. Yeah, I think this is good. Yeah, there's really not a lot of names actually. If you look at it, the only names are scale, bias, kernel, and embedding. So not a lot of parameter types. Um, could actually verify by putting like an else. Uh, could make this a little bit stronger. Now if kernel here for decay, and then like an else and rise an exception. Else rise unrecognized parameter path. Uh, try this just for fun. I think we're good, but let's see if there are like any surprises. Okay, we have a question. Is there any plan to do a from scratch, perhaps closer best practices JAX version rather than converting the original code? Uh, from scratch would be a little bit tough. Uh, if we want to convert like like a nano GPT from scratch, in the sense that we would have to do like all the, let's say, research work that Carpathy's done here. Alternatively, you could just do it from scratch uh, after reading this one. So like you could read the PyTorch one and then they code it from scratch. That could be like an alternative. Um, we're sort of doing it in the sense that we're just erasing all the PyTorch code and doing it the JAX way, like a true from scratch. Could take a little longer using more flexibilities and using attention functions. Um, let's see. You mean using the scratch? I mean using more flexibilities rather than using the attention function in the old code, for example. Okay, that is a little bit debatable if that is more from scratch, like because Flax has a like a self attention function, uh, but this one is from scratch in the sense that we are coding the self attention function ourselves. So I don't know which one is more from scratch, like using like a Flax layer, uh, or using like Nano GPT's function. I think using Nano GPT function for attention is quite good for the understanding. But for the boilerplate of training, okay, yeah, yeah. So it's probably a long term will be better. Because the thing that feels not very from scratch here would be we're using a lot of patterns here, uh, like these methods uh, that they they're funny. Like I wouldn't pre-process perhaps using like a method. I would probably just use like a function in the pure like flex world, but it at least seems to work if we just add like the params to these methods. So I don't think it's that bad if when we when you look at it, it seems that we're regardless we're getting very sensible logic. Uh, but I think we can continue. Uh, what would be interesting would be to do like a port of this code to maybe a flag standard. So like flags examples have a way they are written, uh, like maybe like I don't know, could be like a refactor exercise of coding it in that style. That could be like something that would be a little bit interesting. For now, I think I like this approach because I can just like sort of learn Carpathy's minor tricks, which like the details are sometimes like very valuable to get correct. So just making sure they look similar is like good, and you get all the boilerplate for free. But Yeah, maybe a refactor could be a thing, or once we have this code base, like up from scratch would be just maybe like copy the useful stuff, but then like doing other things differently be something that could be tried. But the optimizer is probably correct. Looks fine uh, according to the description of what we wanted to do here. Uh, so if we continue, okay, here we're not resuming here. Okay, a lot of code here will need to die. This thing, I think Python takes a minute. So just kill this because we're always running in compile mode. We are not going to. I mean, here is probably where we have to code our train step eventually. Like I imagine, I don't think we get there today, but we need to code like a train step. Uh, so okay, from what I see here, we resume it just checkpoints the optimizer. So yeah, resume probably needs to be implemented differently. Uh, so what we're missing, maybe this could be like more of a pure flex approach. We need some flags stuff. So we need to import, import train state. So we want to have the train state, which is an object that will contain our optimizer state and our model. So we want something like this. We want to create a state object. Now we're finally in the flags realm. So yeah, we're gonna pass the apply function. We're gonna pass the parameters, and we're gonna pass the optimizer, which is called this TX. So we don't get confused. Uh, yeah, I don't know. Maybe okay. No, this pattern is not that bad. We get our optimizer. So this is our training state, and here it's just erase this. Uh, Imagining we have something like this. Okay, let's not type this. But let's type that one. Um, and okay, yeah. Curiously, we here can use apply instead of train state apply function because we can pass it as a capture. It's a little bit cheating, but it works. uh, we could also use model dot apply fun that this works. I don't know, sorry, state the apply fun. Uh, the only sad thing is that this apply function has less, as the debugger we can see it, it is less helpful for VS Code because it has less type information. So we just keep apply and pass model via a capture. We get more stuff. So okay, here as the params. Uh, here we have something like uh, I don't know. We could collect X and Y, something like that. And let's see. Actually, what are we calling the inputs? IDX. So um, tokens and targets. I don't know. Puts and labels might be like a good name. Puts labels equals match. So here we pass the inputs and actually we pass the targets as the labels. So yeah, this is a bit funny in the JAX world. I haven't seen this a lot where you pass like the targets to a call and it will optionally give you back the loss function. That is a bit funny. Uh, but it seems to be what we're doing here. And so yeah, logics get sort of ignored. Yeah, so this very simply is the loss function. Uh, so this is a grad function. This is all good. Value and grad. We got our loss. Uh, yeah, this seems to be. And here we sort of just did it. Seems to be okay. Funny stuff here. Estimate loss. Um, get learning rate. Okay. It's get learning rate. Probably have to do it with our optimizer because yeah, this is one of the most. I think yeah, I don't know. Optax has its way of doing things, but one of the things that people often criticize or they want added to Optax is the ability to manually set the learning rate. There's some use cases, but they choose to do it their own way, which is awesome for like a ton of stuff. But for this, uh, it's not that bad, but not sure how much we have to modify. Uh, Might have to do something funny like P plus decay ratio. So what you have to do is pass this to the constructor of the optimizer and pass it to as the learning rate. So because they accept like a schedule. Um, so let's see. And they're conditionals. We like the conditionals. Let's okay. I'm not really about to do because I think this is enough. Create schedule with Optax. So basically, Optax has a way of creating schedules based on the iteration. So we have to interpret this in terms of an Optax schedule, and we need to pass that schedule to the other function that created the Optax optimizer. So we have to basically do this first, pass it there. We can pass it like as a capture if possible. So we don't have to specify all those inputs. We try to do it in this script and send it over to the model, and that would be very easy. I think that would work. And maybe they already have cosine decay. We don't have to. Well, this would just be like this, sort of. But maybe we don't have to do this. And this is already implemented with the schedules from Optext. I've used it. I think. Yeah, I think you can just do it like that instead of doing it like this. But yeah, oops. Sorry, I hope that wasn't that bad. Um, so I'll leave it at this today for next stream. I guess we will finish creating the Optax optimizer and see if we get to run like the training loop. But it feels like we're getting close. Um, so yeah, I hope we can continue doing this and maybe in 2 or 3 episodes. Yeah, a lot of people watch this mostly when like they finish. I mean, not live, but like after the fact. So I'll try to not do like a lot of stuff online if somebody wants to view all of them. But yep, uh, yeah. Anyway, thanks for the people who were attending, and yeah, if you wanna reach out, I guess a lot of people find me on Twitter. That's where I post the link. So I also read the comments, so we can post on both of them on Twitter Other people can see your question, so that's kind of a plus. But yeah, anyway, thanks for joining. Bye, everyone.